Everyone talks about shifting left by moving app tests into CI, but if your strategy stops there, you're still answering 2 a.m. alerts for infrastructure failures. Between debugging fail plans, leaking secrets, and reading wall-to-wall verbose CI outputs, infrastructure automation can be a nightmare. Today, we're looking at how to actually shift your DevOps activities left and fix this. To actually shift left, you need to fix the feedback loop. Here are 2 highly effective ways that you can do that right now. First, bring the right context directly into your IDE using the Model Context Protocol, also called MCP. To be clear, we aren't talking about having an AI auto-write your infrastructure. We're talking about building instant contextual guardrails. It checks your code against your organization's specific policies and the latest provider docs before you even open a pull request. Second, use an LLM to review your execution plans. We all spend way too much time manually parsing hundreds or thousands of lines of verbose plan outputs, and human error still slips through. An LLM review catches the hidden destructive changes, so you don't accidentally force a replacement and do something like drop the production database. Let's dive into the IDE setup first. I'm using Terraform for this demo, but the concept applies to whatever infrastructure as code tool you use. First up, we need to configure the Terraform MCP server for your development environment. You can grab the installation instructions, prerequisites, and command line options directly from the official GitHub repo. Just follow the setup guide, and then copy-paste the config details for your IDE. For this demo, I'm using IBM Bob. If we jump into Bob and I look at the settings, you'll see that the Terraform MCP server is already installed. The status indicator here confirms it's online and talking to the editor. With the bridge established, let's test it. We're starting with a very bare-bones legacy main.tf file that simply provisions an AWS EC2 instance. I'm going to drop in my prompt, which I've already tested, of course. I have an old Terraform configuration in main.tf that creates an AWS EC2 instance. Please use the Terraform MCP tools to check the Terraform registry for the latest AWS provider version. Then refactor my code to follow modern best practices. Split the configurations into versions.tf, main.tf, variables.tf, and outputs.tf. And then use the Terraform MCP tools again to check this best practice. Okay, so I've told Bob to go and do that now. And I've given it access to the Terraform MCP server. And as you can see, the first thing it wants to do is it wants to go get the latest provider version. So I'm always going to be happy with that. So we'll approve that. Okay, now it's searching the providers for AWS. Okay, and it tells me that the latest version is 6.41.0. Now it wants to run a tool to get the provider details. Let's do that. Okay, great. Now it's starting to make new files. Look, there's versions.tf. Great. And it's got the latest version in there for the provider. Okay, and it's taken those things out of my main.tf and it's created a variables file with those things in it, and it's given them nice descriptions. Great. Okay, and now it's gone back and it's edited main.tf to use those variables. Great, and look, here's a nice outputs file. Okay, now if you have a look, it's even verifying the best practices against the Terraform style guide. Oh, great, and it's also made me a README file for this project. Yeah, we'll save the README file too. Okay, and now it's checking that everything follows best practices. So let's let the Terraform MCP server do that too. Great. Okay, great. And let's run Terraform validate. Excellent, the configuration is valid. And as you can see, I've got a nice output here of what's changed to my project. And it's taken that one very simple Terraform file and it's created me a nice refactored one, put variables in, made me a nice outputs file. So when this actually runs, we get meaningful output telling us the details of that EC2 instance. And it's dropped all the variables in here. And as I can see, that's the exact same AMI ID that I originally had in my main.tf. So as you can see, in just a few minutes, we took legacy, insecure Terraform and completely modernized it. This is how you stop wasting hours reading provider docs for syntax updates and start shipping secure, modular infrastructure from day one. Now let's look at the second workflow, tackling the Terraform plan output. You've updated your infrastructure code, you've run your standard Terraform plan, and here's the result. Normally, you're presented with a massive wall of verbose text, either sitting here in your local terminal or buried deep in a CI pipeline. When you're managing complex systems and large-scale infrastructure, these plans just aren't a few lines long. They can be hundreds or maybe even 1,000 lines, and you're probably used to scrolling through this endless sea of text. Maybe it's even in green and red, and you're trying not to miss subtle hidden details, the ones that cause major outages. It's a massive cognitive load, and relying on human eyes to catch every single dependency is practically begging for an incident. Instead of manually parsing this, let's run this through a custom script that I wrote. Now this custom script is feeding my plan to an LLM for contextual review. And while we wait for the model to process this, let's talk about what's actually happening behind the scenes. We aren't just sending raw text. The script takes the machine-readable JSON output from Terraform, wraps it in a highly specific prompt, and asks the model to evaluate the plan, not just for basic syntax, but for architectural intent, security posture, and operational risk. Okay, the response is back. The verdict of my script is, this plan should not be applied as is without first auditing the existing exposure window for the public S3 bucket in wildcard IAM policy, planning for RDS replacement downtime, and tightening the SSH CIDR and KMS key specifications. Okay, let's have a look at what we've got here. Well, we've got a critical issue, 3 high, 3 medium, 2 low. Critical, the RDS instance replacement is forced by a password change, meaning the current database password may be compromised and the replacement will cause downtime. Okay, but it doesn't just stop at the database drop. It tells me that it's publicly accessible. It tells me the current IAM policy is granting full AWS permissions. That needs to be remediated. It's telling me that the security group is open to the internet. I want to just have a look at where this RDS instance replacement is in my plan. Okay. Oh, right there. So easy to miss. So you see, running this locally before a commit or integrating it as an early stage in your CI/CD pipeline drastically shortens your feedback loops. It catches operational risks that a static linter would have missed, and it allows you to deploy with actual confidence. So instead of just hoping you didn't miss a destructive change buried in line 400 of a plan output, you now have a way to catch it instantly. Real shift left for DevOps means giving engineers context where they need, right where they're working. And so whether it's using MCP in the IDE to enforce policies or update an old Terraform file, or having an LLM translate a massive plan into a prioritized risk summary, these are the workflows that may actually prevent a production outage. I'm curious to hear from you. What's the worst infrastructure outage that you've seen that slipped through? Let me know down in the comments. Thanks for watching, and I'll see you in the next one.